Okay, good evening, everyone. Welcome to O-level physics revision lesson. My name is Chu. Today is 13th of September. Okay, I will want everybody on your camera. Ryan and Bei Kwan, can you please both on your camera? Okay, Ryan, on your camera, please. Don't tell me you're at the toilet. Okay, so we shall begin. Okay, today we'll go through the paper that you might not have access to. It's the 2011 paper. I'll be doing the question together with you. Okay, so let's begin. Okay, so I want you all to type out the answer in the chat. Okay, and then you see whether the answer is correct or not. Okay, let's begin. Okay, do question number one. So can you type out the answer? One dot answer. Okay, type out the answer. One dot answer. Okay, so yes, for example, if my answer is E, type out like this. Okay, so everybody type in your answer. Okay, Oscar, well done. Xiaoxing, well done. How about the rest of you? Okay, Yuting, well done. Ryan, well done. Hao Rui, next question, you put in your question number first, then answer. Okay, Hao Rui, well done. Who is the last student? Bei Kwan. What's your answer for question number one? Okay, well done. Okay, some of you might forget how to do what's the definition of potential difference. So how I did this question, I'm doing this together with you. How I do this question is I just do by elimination. Okay, I know that the first one is wrong. Okay, I know the first one is wrong, second one is wrong, the last one is wrong. So therefore, by definition, the answer is C, and all of you got it correct. Okay, do you all remember voltage is the same as work done over charge? Okay, do you remember this formula? Okay, so based on the unit, I'll write in black, unit will be, okay, this is not black. Okay, the unit for volt is V, the unit for work done is joule, and the unit for charge is coulomb. Okay, so therefore the answer will be V is the same as J over C. Is that clear? Okay, let's all do question number 2. Let's begin. Question number 2. Okay, can you all write down the question number first, then the answer? Okay, so for Hao Rui and Bei Kuan, question number 2, write down the question number first and the answer. Okay, Oscar, Bei Kuan, Ryan, Yuting, well done. The last two students. Okay, Yuting, Hao Rui, very good. Xiao Xing, well done. Okay, so all of you got the answer. The answer is C. Okay, so I will not go through this. Let's continue. Okay, do question number 3. You all may begin. Okay, write down the question number and your answer. Okay, I got the answer already. Well done, Oscar. Okay, Ryan, try again. Yuting, well done. Bei Kuan, well done. Xiao Xing, well done. Hao Rui, well done. Okay, Ryan, do you want to try again? Okay, so let me just give you a quick revision. Distance in a speed time graph. Okay, distance in a speed time graph is area under the graph. Okay, so the question here talks about constant speed. So constant speed is down here. So all of you will need to go and calculate what is the area under this graph. Okay, so correct. Everybody got it correct. Well done. The answer is B. Okay, do question 4 now. You think are too fast, I haven't do yet. Let me do. Okay, I got my answer already. Same as Yuting, Oscar, and Xiao Xing. Well done. Okay, so for question 4, the key thing you all must know is average speed is equal to, the keyword is here, total. Okay, total distance over total time. So the keyword is total. Understand? You must know the total. Yeah, is the keyword here is total. Where is? Okay, so 3 of you got it correct. Well done. How about the rest of you? Who need helps? Bei Kuan, Hao Rui, and Ryan. What's your answer for question 4? Okay, Hao Rui, well done. Bei Kwan, Bei Kwan incorrect. Try again. Okay, let me continue giving the clue. So from here, you know the total distance the driver she needs is 75 kilometers. So what is the remaining time left? Okay, so she need to complete the whole thing by 2 hours. Okay, but she spent half an hour in a break and then 1/4 of an hour in a jam. So from here, what's the answer? Okay, Bei Kwan, try again. Ryan, where is your answer, Ryan? Okay, well done. So from here, you can tell you'll be 75 divided by 1, 75 kilometer divided by 1 and 1/4 hour. And from there, you should get 60 kilometer per hour. The answer will be C. Okay, so everybody understand now? Okay, let's go to question number 5. You all may begin. Okay, Yuting, Oscar, Hao-Rui, well done. In exam, can you bring your highlighter? Okay, highlighter and then highlight the keywords so that when you check your work, okay, you can skim through your question faster because you highlight where you want your eye to see. Okay, Qiao Xing, Bei Kwan, well done. Ryan, what is your answer? Okay, well done. Okay, so in this case, when the speed is constant, okay, it means that acceleration is 0. So when F is equal to ma, when A is 0, your net force is 0. So why is A incorrect? Okay, why is A incorrect? Because there is no force acting on the parachute. F equals 0, so why is A incorrect? Why is the answer B? Because there are forces acting on the parachute. Okay, so A is incorrect because there are forces acting on the parachute. If you write down the word there are no net force, then it will be correct. But when you say that there are no forces acting on it, then it is incorrect. Clear so far? Okay, let's do the next question. Okay, do question number 6. Hey, sorry. Okay, I got the answer already. Oscar, well done. Bei Kwan, try again. Xiao Xing, well done. Hao Rui, well done. Okay, Xiao Xing, well done. Hao Rui, well done. Yu Ting, well done. Oscar is asking me, is it the same question as 2016 question 6? I don't know, I can go and refer, but it might be there are some questions that might appear again. Bei Kwan, incorrect. Ryan, incorrect. Okay, let me go through this question. When you see that the nail, okay, as I said, bring your highlighter to exam. When you know that the nail does not move, okay, means that it is not moving, right? So it's not moving means that your speed is 0. Your acceleration is also 0. So your net force, if this is 0, your net force is 0 as well. Okay, so the net force acting on the nail should be 0 Newton. Okay, so two of you gave me the answer C. So look at C. Let's see what's happening here. Okay, so we compare T and W. T and W will give you a net force of R going down. So there's 2R. What happened? Your net force will be, when there's 2R, your net force will be 2 of R. Okay, so there will be a net force for answer C. Okay, whereas you look at the, okay, so before I continue, Ryan and Bei Kwan, can you all try again? Can you try again? Okay, if you are not sure, just tell me not sure. Bei Kwan say D. Okay, Bei Kwan, the same thing. Can you see this? W and R will give you the same as T. So 2T will give you a 2T resultant force. So the resultant force of this is 2T. Okay, there's a resultant force, there will be acceleration, and your speed will be 0. Okay, Ryan. Bei Kwan, you're correct now. Ryan, what's your answer? Or are you need help for this question? Ryan, I mentioned D is incorrect because the green color and T are the same. So when they are the same, they'll produce double the force of T. So you get a resultant force of 2T. Okay, Ryan, B is the same thing. Can you see? Okay, I use another color. Can you see for B? T and R, can you see they go from this angle to this angle? It's the same as W. So my resultant force will be 2W. Okay, so can you see if my starting point, for example, my starting point is here. Okay, this is my starting point. Why did I spell starting wrongly? Okay, this is my starting point. Okay, I start moving in this direction. I start going down. Then I go left. Then I go up. Can you see? It goes back to the original point. So therefore, the force is 0. Get it now? Clear? Right, okay? Okay, let's do the next question. Okay, at least you learned something today. Bei Kwan, you understand also? Okay, do question 7. You all may begin. When I tell you the answer, I got it. That's how fast I do. Let me read. Okay, I got the answer already. So those who do it before me means you're faster than me. Okay, Oscar, well done. Ryan, well done. Qiao Xing, well done. Hao Rui, well done. Okay, what is the word I will highlight here? I will highlight the word identical. Yi Ting, well done. Who is the last student? Bei Kuan, what's your answer? Bei Kuan, incorrect. Yeah? So when you see that they are identical, their density is the same. Okay, the density is the same. So Bei Kuan, what's the answer? Try again. Okay, well done. So the answer for this is A. Okay, everybody okay? So when the bricks are identical, they have the same density. Okay, question number 8. Let's begin. Okay, the keyword here is horizontal. Okay, I got the answer already. Qiao Xing, Oscar, Ryan, and Yi Ting, well done. Left with Hao Rui and Bei Kuan. Okay, Hao Rui, well done. Bei Kuan, what's your answer? Okay, maybe you look at this first. Which of the answer is correct for this system? Okay, you want this to be balanced. So what should the value of Q and R so that this system in yellow will be balanced? Okay, Bei Kuan. Okay, the formula you need to know for this is moment is equal to force times perpendicular distance. And you also need to know the principle. Chelsea, you will join again. You also need to know the principle of moments. So you need these two ideas. Principle of moment means clockwise moment is equal to anti-clockwise moment. Okay, Bei Kuan. So clockwise is this. This is clockwise and this is anti-clockwise. So you should know that 20R is equal to 10Q. So 2R is equal to Q. So in this answer, which one where Q is double of R? Okay, Q is double R, it will be only C and D. Okay, so A and C is wrong. Okay, same thing now. This force downwards will be the total mass. The total mass, okay, let me call this PQRS. This total mass will be either 30 or 60. Can you see? Because 20 plus 10 is 30, 40 plus 20 is 60. So if this is 30, what would this value be? If this is 60, what would this value be? Is that clear? Okay, Bei Kuan understand now? Okay, so the answer will be C. Clear? So Bei Kuan got it. Let's continue. Hey, Bei Kuan, your physics so bad, man. So the past 2 years, I've been talking to who? Okay, question number 9. You all may begin. Okay, I got the answer for question 9. Whoa, I'm faster than all of you. Lee Ting, well done. Okay, Yu Ting, well done. Hao Rui, well done. Qiao Xing, Ryan, well done. Oscar, Bei Kuan, well done. All got correct. Well done. The answer is C. Okay, let's do question number 10. Okay, I got my answer for 10. Okay, Yu Ting, correct. Qiao Xing, try again. Okay, well done, Bei Kuan. Oscar, well done. Hao Rui, well done. Qiao Xing, correct now. Ryan, where are you? You are still eating, man? Okay, very good. All of you got the correct answer. For this question, you all must know that pressure is H rho G. So you need to know pressure 1 equal to pressure 2. So H rho equal to H rho, H1. Okay, the G is cancelled off because G is a constant. Okay, so from here, you suck in all the value, you should be able to get the density of liquid X. Clear so far? Can? Okay, very good. So we are 1/4 there. So at this rate, we'll finish at 11. Okay, can we do faster? Question 11, let's begin. Okay, I got my answer already. Ryan, well done. First to get it correct. Well done. Yu Ting, very good. Oscar, very good. Hao Rui, well done. Xiao Xing, well done. Yu Ting, well done. Last student, Bei Kuan. Bei Kuan, incorrect. Okay, the answer for this is D. So what are the, at P, what is the potential energy? It is at a high point, so it's GPE. At Q, this will be stretch, so it's the elastic potential energy. Okay, so both of these P and Q have potential energy. At P, it is gravitational. At Q, it is elastic. Bei Kuan, understand now? So all of you can do question 12. Bei Kuan, get it? Okay, continue. Question 12. I haven't read leh. Oscar, you're very fast. Let me read first. Hey Ryan, not so fast there. If not, I'll miss out your answer because from my point of view, I see it as all of you come the answer together. So later then give the answer, Ryan. Hey, question 12. Yeah, I'm still doing it. Wait. Oh, okay. I think I know how to do it. Wait. Okay, I got the answer. It took me a long time to do. Okay, question number 12. Oscar, well done. Ryan, incorrect. Bei Guan, well done. Yiting, well done. Hao Rui, well done. Yeah, it took me a bit of time to do question 12. Because I'm going to use the kinetic energy formula. Chelsea, well done. Okay, but what should you do? What should you do? So this is the energy gain. Okay, this is the energy gain. So how much work is required to gain this energy? Okay, so the work done is the force times displacement. S is displacement and not speed. And so the amount of work done will produce the kinetic energy. Okay, so the force will be kinetic energy divided by displacement, and then you get the answer. Okay, Ryan. And Ryan, can you get the answer again? All right. So from here, I let my kinetic energy or the work done be 200,000 joule. My displacement is 100 meters, and therefore you get the answer C. Okay, let's do question 13. Ryan, you give your answer again. Let me read the question. Question number 13. Those who are fast can also read 14. Okay, I think the answer is correct for Yiting, Ryan, and Hao Rui. Okay, very good. Oscar, well done. Bei Kuan and Xiaoxing, what's your answer? Okay, Pei Kwan, well done. Xiao Xing, well done. Okay, so for 13, the power is the same as energy over time. Okay, so what energy are you gaining from here? The energy you're getting from here is gravitational potential energy, which is mgh. Okay, so you need to know the height, which is the vertical height of the stairs. Okay, the time you also need. Okay, mg is the same as weight, which is the weight of the student. So the only thing you don't need is the horizontal distance of the stairs. Okay, question 13, are you all clear? Okay, do question 14 now. Okay, for this question, the keyword I will highlight will be this. So based on this, Ryan, Yuting, Pei Kwan, Hao Rui, and Oscar, they are all correct. Who's the last student? The last student is who? Okay, Xiao Xing, well done. Okay, so the answer for this would be D. Okay, I don't think I need to explain this. Let's us move on. Okay, question number 15. Let's begin. Okay, I got my answer. Yiting, well done. Oscar, well done. Pei Kwan, well done. Xiao Xing, well done. Hao Rui, well done. Ryan, well done. Everybody got it correct. The answer is B. Let's do question 16. Okay, I got my answer for 16. All of you are very fast. Xiao Xing, first one to get it correct. Ryan, well done. Oscar, very good. Yiting, very good. Hao Rui, well done. Last student is Pei Kwan, very good. Oh, you got it. So this is silver. Silver reduces radiation. Clear so far? Okay, next question. Question number 18. So suddenly we are speeding up. Okay, let's do question 18. Okay, I got the answer for 18, which is different from Chelsea. Okay, let me see what the rest give. I could be wrong. Okay, I got the same answer as Hao Rei, same answer as Yiting. Okay, Chelsea, you try again. Oscar got the same answer as me. Well done. Pei Kwan incorrect. Chelsea incorrect. Okay, let me go through first. First of all, when you see 40 seconds by 100 watt heater. Okay, so for this, you all remember power is equal to energy over time. So energy is equal to power times time. You have learned this also in the electricity topic. So how much energy is provided by the heater? Is provided by 100 watts multiplied by 40 seconds. You're providing 4,000 joule of energy to the copper. Okay, Chelsea, you got it correct. Do you know why? Ryan, well done. Pei Kwan, try again. Okay, then if you want to memorize by formula, okay, formula is Q equal to MC theta. Okay, so the energy provider is 4,000. The mass provider is 2. Okay, the C is given here, 400. And then you got the theta here. Okay, so this is the formula that you need to memorize if you want to memorize. Okay, and then you'll get the answer 5 degrees Celsius. What if you cannot remember the formula? Can you actually investigate using the unit here? Okay, can you see from the unit? It tells you that the specific heat capacity is equal to J is energy divided by the mass and the temperature. Understand? So specific heat capacity, this value is 400. Okay? Energy, you know that is 4,000. The mass, you know is 2. So based on this, can you do the answer? Okay, so if you make temperature the subject, you should get 5 degrees Celsius as well. So what I'm trying to teach you here is even if you forget this formula, you can get a lot of clue from the unit. You understand? So the specific heat capacity here is 400. So 400 is equal to what? Equal to energy over the mass and the temperature. Energy you already calculated is 4,000. The mass you know there's 2 kg. Can you see here? So from this unit, can you do the question as well? Is this something useful for everyone? If it's useful, give me a clap reaction. Okay, so let's do question number 19. You all may begin. This question is similar to just now that question. Okay, I got my answer already. Yiting, well done. Oscar, well done. Hao Rui, well done. Ryan, well done. Okay, Bei Kwan, incorrect. Who's the last student? Chelsea, you need help for this? Okay, Chelsea, well done. Okay, Bei Kwan, let me just quickly explain this question to you. Okay, this is your energy use. Okay, energy is power times time. Okay, so must change everything to SI unit. So 2000 times 5 times 60. Okay, so this is your SI unit because you must change to second. You must change to watt. Okay, so 2000 times 5 times 60. Okay, is 600,000 joule. Okay, I will not use a formula to explain this. So let me share with you. 0.2 kg of water requires 600,000 joule of energy to boil. Clear? To boil. How much energy you need for 1 kg of water to boil? Okay, why do I say that? Because you look at the unit, is joule per kg. So it means that how much energy you need, okay, to vaporize 1 kg of this water. Okay, so if 0.2 kg requires 600,000 joule, 1 kg require how much? Okay, so you all understand what I'm trying to teach you all here. Not just memorize the question. Okay, for this, the formula that you all need to memorize is Q equal to ML. Okay, but what I'm trying to explain is based on the unit, you can actually guess what is the question asking you. And the question is saying that 0.2 kg of water requires 600,000 joule of energy to boil. So how much energy is required to boil 1 kg of water? Is that clear now? Okay, Bei Kwan, you understand? You understand? You give me a yes reaction. Okay, question 20, everybody can start doing. Okay, I got the answer for 20. Yiting first to give me the correct answer. Well done. Ryan, well done. Oscar, well done. Qiao Xing, well done. Hao Rui, well done. Bei Kwan, well done. They all got the correct answer. The correct answer for this is energy. Okay, so the particles of the rope is just moving up and down. Okay, the particles of the rope are just moving up and down. It is the energy that is moving left and right. Clear so far? Oh, okay. All got correct. So I'm going to explain further. Let's continue. Question. Hey, wait, where is 21? Oh, okay. Okay, let's do question 21. You all may begin. Okay, I got my answer ready. Okay. Yiting, well done. Okay, 21, Yiting, Ryan, Hao Rui, Oscar, Qiao Xing, well done. Bei Kwan, incorrect. All your angle of incidence and reflection, all the angle, right, is always to the normal. Okay, this is your normal. So in this case, this is your incident ray, this is your reflected ray. Understand? So Beikwan, you did question 40 already, so fast. Okay, so in this question, the answer is A. Now everybody got it correct. Well done. Hello, 21 eh. Beikwan, why you so blurred today? Question 22, let's begin. Okay, let me do question 22. Okay, I got my answer. Qiao Xing, well done. Beikwan, try again. Ryan, well done. Hao Rui, well done. Yuting, well done. Last student is Oscar, well done. Okay, so let me explain this question. Same thing, you have the normal. Okay, so your I is 45 degrees. Okay, if I were to continue with this ray, it will go this way. Am I right? Okay, but because glass is a more dense material, okay, it will actually bend inside. Okay, this is the original path. This is the refracted path. Okay, so you need to actually calculate this angle of refraction. Okay, so n is equal to sine I over sine R. Okay, Beikwan, can you do this? Your n is 1.5. This one you must remember. I cannot help you. Your sine I is actually 45. Your sine R you don't know. You make R the subject. Okay, what's your answer be? Okay, you should get about 28 degrees. So your this R is 28 degrees. So the question here is, okay, why is 28 not correct? 28 is not the correct answer because the question asking how many degrees does the light ray change direction? So you're trying to find this angle. This is how much angle it change direction. Okay, so the total here is 45. This is 28. What would this angle be? Understand? So this is like a tricky question. So the answer will be C. Is that clear, everyone? Okay, everybody do question 23 now. Hey, you're very fast. I haven't do yet. Oh, I got my answer. Okay, Yuting, well done. Ryan, well done. Beikwan, well done. Qiao Xing, well done. Oscar, well done. Hao Rui, well done. Okay, the key word here is converging. So you want to converge, means the ray should come together. So what you need to do is, for every ray, you go and see what is the original. So can you see for A, it comes together. So A is correct. Okay, I'll give more example. If B, if it will go straight, then it move further away. Can you see? It actually move further away. Okay, same thing for C. It move further away. Same thing for D. The ray actually move further away. Okay, so only A is correct. Everybody got this correct. Well done. Well done, everyone. Okay, question number 24. Let's begin. Yiting, well done. Yiting, have you done this paper before? Oscar, very good. Ray, very good. Chelsea, well done. Ryan, well done. Okay, everybody got this correct. The answer is gamma. Okay, so the side that is towards gamma are the one with the highest frequency. Okay, it actually vibrate the most, so it's the most dangerous. Okay, so gamma ray, X-ray are all very dangerous, even UV as well. Okay, these are all towards the high frequency ray. Okay, so for 24, B is correct. Well done. Okay, let's do question number 25. Okay, I got my answer for 25. Chelsea, correct. Ryan, correct. Ray, correct. Oscar, well done. Last two students, Yiting and Bei Kwan. Yiting and Bei Kwan, well done. Okay, so loudness determine your amplitude. Okay, so different loudness, different amplitude. Okay, pitch determine the frequency. So same pitch will give you same frequency. Understand? But because they are all they are all sound in the air, so the sound will travel in the same speed. Okay, so those with the same speed one will get the correct answer. So the one that's only both correct will be C. Okay, everybody understand this question now? Okay, well done. Let's continue. Okay, do question 26. Okay, I got my answer already. Yiting, well done. Ryan, well done. Ray, well done. Oscar, well done. Xiaoxing, well done. Bei Kuan, what's your answer? Okay, for this question, you use the right hand grip rule. Okay, Bei Kuan, go and try. Using the right hand grip rule, what will your answer be? Bei Kuan, are you there? Do you need help? Okay, so quickly do. Bei Kuan, what's your answer for 26? Okay, use your right hand grip rule to do question 26. Okay, incorrect. Okay, in the object P and Q, okay, the P and the Q should have different pole. Same thing for R and S. Okay, so for Bei Kuan, you tell me that P and Q are the same pole. Okay, definitely wrong. Okay, so this one definitely wrong. Okay, so A and D definitely is wrong. Is that clear? Okay, then I want you to use the right hand grip rule. Your right thumb will be pointing to the north. So the north is at the left side or the right side. That's the main thing. Okay, Bei Kuan, try again. Okay, so this is your current. Your current is going behind, come from the bottom, front, and then over the top. So where would your north pole be? Okay, use your right hand. Is it grip over it or grip under it? Okay, Bei Kuan, what will it be? So can you see? Down here, will be like this. The current will be like this. Am I right? So if we were to draw your hand, how to draw? I also don't know how to draw. Okay, your thumb will be pointing this way. Can you see? Because your finger is going Okay, I draw my finger behind. Can you see this is your thumb? Your thumb is this. Okay? Very ugly, right? My drawing. Can you see? So what's happening here is your finger will be the one. Can you see? Oh, this is not nice. Okay, your finger is going down behind. Okay, so your fingers will be the direction of your current. So your thumb is pointing to the left. So the left will be the North Pole. Understand so far? Okay, so everything is good. Let's continue. Question 27. Let's begin. 27, you may begin. Okay, I got my answer ready. Yi Ting, well done. Xiaoxing, well done. Ryan, well done. Hao Rui, well done. Oscar, well done. Bei Kuan, what's your answer? Okay, Bei Kuan, well done. The answer here is C. Okay, everybody do question 28 now. Do question 28. You all may begin. Okay, I'm still doing question 28. Okay, I got my first I got the question wrongly. So looking at your answer, I think you are correct. Yi Ting, well done. Oscar, well done. Hao Rui, well done. Ryan, incorrect. Okay, why I got the question wrong? Because I did not highlight. I did not see the word this. Okay, so because of this, I got my answer wrong at first. Then I see why my answer is different from yours. Okay, so the answer, okay, Ryan, try again. Bei Kuan, well done. So who else haven't give the answer yet? Chelsea and also Ryan, try again. Chelsea, incorrect. Incorrect. Okay, Chelsea, X and Y got attraction. So positive and negative can attract. X and Z also got attraction. So positive and negative can attract. So Chelsea, well done now. Ryan, you are still eating. Why your camera still off? Go on your camera now before I remove you from the class. Don't tell me you eat for 1 hour and 20 minutes. Okay, Ryan, what's your answer for question 28? 28. Okay, Ryan, well done. Okay, so the only one that is incorrect, yeah, is B. Why? Because positive and positive, S and Z, if they are the same charge, there will be a force of repulsion. Okay, so therefore B is incorrect because X and Z cannot be the same. Is that clear? Okay, very good. Let's continue. Next question, 29. You all may begin. Chelsea, that's your answer for question 29. Yeah, I don't understand the question. Anybody can explain to me? What the question mean by what length of wire is needed for the second resistor? Who can explain to me what is the question asking? Anyone can help me? Okay. I got it. Okay. I understand what I mean already. Okay, I got the answer already. I think it took me a while to understand. Okay, Chelsea correct, Oscar correct, Yiting correct, Hao Rui correct. How about the rest of you? Okay, I was a bit confused because I was thinking the wire has double the resistor. That's not correct. Okay, the keyword here is same material, area of this, and what length will produce this. Will produce double the resistance. Okay. Ryan incorrect. So who is the last student? 1, 2, 3, 4, 5. Bei Kwan correct. Ryan, you need help? Right, I'm going to remove you from the class. You still don't on your camera. My last warning to you. Okay, Ryan, do you need help for this? Bei Kwan, well done. Okay, the rest of you can do number 30. Hello, Ryan, I'm asking you a question. Do you need help for question 29? Okay, so everybody got the correct answer. The answer is A. Okay, so if your area is much smaller, the resistance increased by 4 times. Okay, so you only want your resistance to increase by 2 times. So your length has to be half so that your resistance will be increased by 2 times and not 4 times. If your length is the same, your resistance will be 4R. Is that clear? Okay, all of you do question number 30. Okay, 30, I got the answer already. Yi-Ting, well done. Ryan, incorrect. Oscar, well done. Hao Rui, well done. Okay, so this is an alternating current supply, meaning the current will go to and fro, to and fro, to and fro. Okay, so this resistor connecting to the alternating current will actually have AC. You actually carry current in two directions. Okay, Chelsea incorrect. Okay, so I'll give you a clue. Okay, so can you see down here? This circuit is connected to the AC power supply, and this circuit has nothing in between. These two resistors will carry current in two directions. Okay, Chelsea, try again. Okay, Chelsea, well done. Ryan, well done. However, if I look at this pink color, you like pink? Okay, you see the pink color side of the circuit. There's a diode here that only allows direction in one direction. So for these two resistors, will only allow current to move in one direction. Okay, so the answer for this is 2. Everybody clear now? Okay, we have 10 more questions. Let's do quickly. Next one. 31. Hurry up. Do quick. Okay, I got my answer. 31. What's your answer for everybody? Right here, what's your answer? Right, incorrect. How well done. Okay, for those who are confused, let me draw this in a simpler manner. Can you calculate A2 first? Can all of you calculate A2 first? Okay, Yi-Ting, incorrect. Okay, I want all of you to calculate A2 first. I redraw it like this, should be easier to see, but it looks ugly. Let me draw again. Okay, everybody go and calculate A2 first. Then from there you can do your A1, A3. Okay, Yi-Ting, correct now. Oscar, correct. Ryan, incorrect. Ryan, totally wrong. The rest of you, what's your answer? What's the value of A2? Chelsea, well done. Ryan, incorrect. Next thing I want you all to see, these two currents should be the same, right? This current here, okay, this whole chain here should have the same current, am I right? Because it never go any other place. So A1 and A3 has to be the same. Okay, so B and D is wrong. Hey, wait, sorry, this is not wrong. So A1 and A3 are the same. Okay, so B and C are wrong. Am I right? Got A1 and A3 are different. So what is the answer? Okay, Ryan, you got it correct now. Well done. 1, 2, 3, 4, 5. Who is the last student? Last student. Bei Kwan, what's your answer for this? Can you find A2? V equal to Ri. Okay, number 2. So what's the voltage? 4. What's the resistance? 2. So what is the value of I2? Okay, I2 need to be 2 ampere. Understand? Okay, quite incorrect. Can you see here? The total potential difference is 4. Okay, if I were to put a voltmeter here, I put a voltmeter everywhere here, all the V will show 4 volt. Okay, so the answer for this is D. Everybody understand now? All of you understand? Yes or no? If you understand, give me a yes reaction. Okay, let's do the next question. Can we do doubly fast? 32. What is the power produced in this resistor? Okay, quickly do, quickly do. Okay, I got my answer ready. Yiting as usual, the fastest. Well done. Yiting correct. Oscar correct. Yiting, have you done this before? Hao Rui, well done. Xiao Xing, well done. Hey, how come you got 2011 paper? I thought your 10 series all start from 20121. But do you still find today's session useful? Ryan, well done. Yes, Yiting. But last year the question are all jumbled up. Ryan, well done. How about the rest of you? What's the answer for this? Okay, power is equal to VI. Okay, which is equal to V squared over R. Okay, if you were to put in your value, you should get your answer. And the answer is? Bei Kwan, what's your answer? Okay, so answer is C. Well done. Okay, do question number 33. 33. Hey, I need time to do 33. Why you think so fast, right? I also do this question long time ago, but I cannot do so fast. Okay, all of you tell me B. So which of these 5 events is correct? Can you tell me? Can you tell me which of these 5 events will cause the fuse in the plug to blow? Some of you tell me 3rd and 4th. Some of you tell me 4th and 5th. How about the rest of you? Okay, which one will not blow? These two confirm will not blow. Correct? Okay, so for this question, what's the answer? Let me refer to my book. Hey, my book don't have the question. It's in another book. Okay, some of you say 3 and 4. Some of you say 4 and 5. So which one will cause the fuse in the plug to blow? So for it to blow, you need to have a very high current. Okay, so when the live wire touches the neutral wire, okay, there is no resistor in between. So you'll definitely have a high current. So the fourth one definitely will cause it to blow. So what happens if the person touch the live wire? Will it cause it to blow? A live wire touches the earth wire. Okay, when the live wire touches the earth wire, it also provide a path for the current to flow. Okay, and then you have a high current as well. Okay, so the last one will also cause the fuse to blow. Okay, now the next question. If a person touch the live wire, will it actually blow? Okay, I'm not sure about this. So let's skip this for a while. So the answer is either 2 or 3. Okay, I will go through this next week. I'll let you all know again. Is that okay? But how many of you are convinced which of these 3 will allow it to let the fuse blow? How many of you can give a definite answer for this? A person touch the live wire. Okay, I'll go through this in a while later. Okay, let's do question 35 quickly. Which part needs to be made of the iron, soft iron, to increase the efficiency of the motor? $35, what's your answer? Ryan, you're doing 34, 35. Yiting, well done. Xiaoxing, well done. Ryan, well done. Bei Kwan, incorrect. So this one is a magnet. And it's a permanent magnet. And you really want a permanent magnet to use a hard magnetic material. Okay? So hard magnetic material usually is steel, not soft iron. So B is wrong. Ryan, Hao, Ray, Oscar, Bei Kwan, correct. So answer is A. Okay, so you need this to be a soft iron for it to be to work better. Okay, the D and the C don't need to be magnetic, so doesn't matter. For this permanent magnet, you want it to be a permanent magnet, you want a hard magnetic material, so steel will be the best. Okay, we're ending already. Let's do question number 36. You all may begin. Hey, we missed 34. Later you go back to 34. Okay, do question 36. Okay, Xiao Xing, try again. Yi Ting, well done. Ryan, try again. Bei Kuan, well done. Hao Rui, well done. Oscar, well done. Okay. There will be a induced EMF when there is a change in magnetic flux. Is that clear? So when there's a change in magnetic flux, there must be motion. Okay, so when the magnet is oscillating up and down, at which point where there is no speed? Okay, at which point when there's no speed? The point where there's no speed will be at point P and point R. Is that clear? That's when at that point, instantaneously at that point, it is not moving. The speed is 0. Okay, so the answer for this is B. Is that clear? Everyone? Okay, 34. We did not do 34 just now. Okay, let's do 34. In which direction is the force on Q? Okay, you all may begin. 34. Okay, I got my answer ready. Chelsea, well done. Yi Ting, well done. Oscar, well done. Next three of you, what's the answer? Ryan, well done. Okay, so how? Okay, you use a right thumb rule. You know that the magnetic field is like this. So can you see in the middle? It will cancel out. Okay, so eventually your magnetic field will be in this manner. Understand? So in this manner, okay, it means that you are pushing the two wires together. So when you push the two wires together, the answer will be D. So all we got it correct. Well done. Bei Kuan, are you able to draw this? Do you know why it's in a clockwise motion? When you see a cross, it means that the wire is going into the plane. Okay, cross is into the plane. Oh, okay. Okay, we're ending. Let's continue. Okay, question 37. You all may begin. Transformer. Okay, I got my answer. Chelsea correct. Ryan incorrect. Try again. Okay, Bei Kwan, well done. Chelsea, well done. Sorry, Bei Kwan haven't given the answer yet. Chelsea, well done. Hey, where are the rest of you? Why there's no answer one? Hao Rui, well done. Oscar, well done. How many of you need help with this? Can you see? This is 12 volt and 6 volt. So your starting point, your AC is to lamp has to be 2:1. Is that okay? So that is your final result. Okay, so we go through one of the answer that you all gave me. Yiting gave me B, for example. So if I put P, okay, if I put P as 50 here, right? So it's 50:1000. Okay, so your AC is 2. Okay, so your AC is 2 volt. So 1000 will become, sorry, not 2 volt. This is 12 volt. Okay, 12 volt divided by 50 times 1000. Your Q will be 240 volt. Okay, so that is what happened to your Q. Then your S is 240 volt. Okay, which is 500:50. So you divide by 10. So you end up down here as 24 volt. Okay, so B is incorrect. Okay, understand anything? So B is incorrect. Okay, then Ryan tell me C. C, okay, so this one is divide by 20 or times 10. So Ryan say put R here. R to S. R to S, you multiply by 10. So 12 volt multiplied by 10, I get 120 volt. So in this case, 120 volt, P to Q, I divide by 20. P to Q, sorry, P to Q, I multiply by 20. Okay, I multiply by 20, I will get 2400 volt. Okay, so for Ryan, if you choose C, you get 2400. Wrong, you need to get 6 volt. So what is the answer for this? The rest of you, what's your answer? Hey, okay, let me re-explain this again. P to Q, I multiply by 20. R to S, I multiply by 10. Okay, so all of you started off with 120 volt. Okay, so P to Q, I multiply by 20. So 120 volt times 20, all of this will become 2400 volt. 2400 volt. Okay, so here is the same thing, no change. Then R to S, I multiply by 10. So it becomes 1200 volt. Okay, so these two, I multiply by 20. These two, I multiply by 10. Okay, so R to S, R to S, I multiply by 10. I multiply by 10, I get a very big value, 24000 volt. Then S to R, I divide by 10. I'll get 200 and, okay, sorry. I used too big a number. It should be 12 volt. Okay, let me redo the whole thing again. Sorry. I'm sorry. Okay, so it's 12 volt, 12 volt, 12 volt, 12 volt. So P to Q, I multiply by 20. R to S, I multiply by 10. So end up here, I will get 120 volt. Okay, this one I'll get 240 volt. Then R to S, I multiply by 10. So I will get 2400 volt. Wrong. Then S to R, I divide by 10. So I will get 240 volt. Divide by 10, I will get 24 volt. Also wrong. Then P to Q. P to Q, I times 20. So 120 times 20, I get 2400 volt. Also wrong. Then Q to P, divide by 20. So 120 divided by 20, I get 6 volt. My answer is D. So question number 37, the answer is D. Are you all clear about this? Okay, the number of turns is proportional to the number of the voltage. Clear now? Okay, we are ending soon. 38, what's your answer? Yeah, I got the answer for 38. Okay, question 38. Eating correct. Hao Rui correct. Ryan try again. Sorry, Ryan got correct now. Chelsea correct. Oscar correct. How about the last student? Last student is who? Last student is Bei Kwan. What's your answer for this? Okay, as the voltage stays the same, the voltage on top here, let's say this is 0 volt, this is V. So this V stays the same here. L1 will always remain the same. Clear so far? Then, when there is an increase in light, so when the light increase, resistance decrease. So the resistance go down for here. So the proportion, percentage here go up, correct? Because this goes down, the percentage go down. As the percentage go up, the V, we're talking about V. Okay, we will to divide the potential here because this remains the same, the resistance remains the same, but the resistance of this go down. If I were to put a voltmeter here, this voltmeter will go up. So because the resistance of this is lesser. Clear so far? Okay, so as the voltage or the potential difference of the lamp increases, by brightness of the lamp will increase. Okay, answer will be D. Okay, Kwan, you understand now? Okay, for example, at first, it could be 100 ohm and 100 ohm. Okay, so the lamp takes up half the voltage. But when this becomes, let's say 20 ohm, and this will still remains 100 ohm. Can you see the proportion? This at first it takes up half the voltage. Now this will take up 5/6 the voltage. Understand? Because the total is 120, it takes up 100 ohm. So the voltage across is V, it takes up 5/6 of the V because of this proportion that goes down. Okay, you understand what I mean, Bei Kwan? Okay, last two questions. Quickly chop finish. Question 39. Okay, this question is quite similar to a previous question. Tiao Xing incorrect. Bei Kwan incorrect. Okay, let me look at the answer for this. Oscar, well done. Bei Kwan, your new answer should be correct. Ryan, try again. Yi Ting, correct. Okay, so basically, as temperature rises, the resistance goes down. So the resistance of this goes down. So if I put a voltmeter here, should the voltage go up or go down? Taking into account that this is still 6 volt. And then this resistor remains the same. Okay, Ryan, same as just now. When the resistor here goes down, the proportion of the resistance over the whole resistor, does it go up or go down? If the proportion goes down, V will go down. If the proportion go up, V will go up. So I give an example. At first, it is 100 ohm and 100 ohm. And now this one become 20 ohm, and this is still 100 ohm. So the voltage for this will be more or less. Can you see down here? This, the total is 200 ohm, correct? So this takes up half the voltage. Now, the total voltage in resistor is 120 volt, 120 ohm. So now this will take up 1/6 of the voltage. So half voltage to 1/6 is increase or decrease? You understand what I mean? This is the total resistance. So when the resistor reduce, the proportion also reduce. Okay, so the answer for this is A. Is that clear, everyone? Okay, very last question. Last one. Last question. Okay, I got the answer for the last question already. What's your answer, everyone? Okay, Xiao Xing, you may go. Yi Ting, you may go. Oscar, you may go. Hao Rui, you may go. Okay, left with Bei Kwan and Ryan. Chelsea, you got any question for me? Okay, if not, you may go. Ryan, incorrect. What is the period? If this is 1/400 second, this is the period. What is the period? Bei Kwan incorrect. The period will be half of this, which is 1/800 of a second. Then frequency is 1/period. So can all of you tell me what's the frequency of this signal? Okay, Ryan, you may go. Okay, Bei Kwan, what's your answer? If the period is 1/800, I let the T be 1/800. So what is your frequency? Count again, Bei Kwan. Hello, Bei Kwan, you substitute your T equal this. Then can you find your F? Hello, Bei Kwan. I will say that your T is your 1/800. So what's your answer here? Hello, Bei Kwan. I really give you the working. What's your answer here? Understand now? So you get 800 hertz. Okay, answer is D. Okay, Bei Kwan, you may go. Okay, thank you and good night to everyone. Goodbye.